I'm CK. Tonight we're doing my favorite thing, which is building another oscillator. Tonight we've got a VCO from Feedback Modules. They're 259 VCO. Feedback Modules is out of Bucharest, Romania. I have not built anything from them before, so we'll see how it goes together and see how it sounds. I'm looking forward to it. Hope you enjoy the video. Here's the bag. Feedback Modules out of Bucharest. Let's see what we got. It's a big bag. It feels like there's a lot of stuff in here. We got a sticker. Always good to have a sticker. Put that on my sticker wall. So let's look at the front panel first, because it'll give us a clue to what everything else is going to be like as we go along. And as usual, can't open the bag, so I just take scissors and attack it brutally. By the way, I picked this module up from thonk.co.uk. They're my go-to place to get eurorack modules. So, here we go. Looks like we've got outputs for a sine, triangle wave, sawtooth wave, and a square wave. Outputs, high-low range, not sure exactly what that is, frequency control, and fine-tuning, key CV, which I assume means note CV, CV something, minus and plus, I don't know what that is, modulation, lock gain, I don't know what that means, CV in, so I'm not sure what the difference between those will be, modulation in, and lock in. So the lock is interesting in having three, it looks like 2 CV jacks inputs is going to be interesting. So let's look at the board. This is the panel board, which goes right behind this, so we can see what these things actually are. So yeah, these are all jacks. The high-low range is a switch, looks like a 3-position switch, or 2-position switch, double pole, double throw, and it's LEDs. We've got a potentiometer in fine and a potentiometer in frequency. Key CV is another jack, and then 3 pots along here and 3 jacks along here. Now as we look at the board, looks good. The traces are very big. This is a very straightforward traced board. All through hole plated, which is excellent. All the values are listed on the silk screen, so you could build it without a parts guide or build list if you want. Backup board, got some ICs, got a whole bunch of pin headers, looks like. Another pair of ICs, power connector goes there, and a bunch of other things. So looks like a lot of stuff put on the board. So that will be interesting and fun. And unfortunately, we've got bags within bags within bags. Way too many bags. I'm going to dump some of this stuff out because it is looking interesting. And we've got a pair of matched transistors. Some LEDs for high-low. Headers. Molex connector. The sockets are these round type. I don't like them all that much. I prefer the rectangular sockets. I feel that they're more secure, but that's personal preference more than anything else. Then we've got some op amps, and I don't know what that is. THAT 340. Solder without socket, it's direct connected. Huh. I'll have to look that chip up and see what it is. And then some mechanical parts, standoffs and so on. I'll put those over there. Looks like just standard passive components, caps and resistors in that bag. And in this bag, more caps and resistors. So we'll be doing a good bit of soldering on this. Let's see what else we got in here. Mechanicals, jacks, knobs. These look like good knobs. I'm going to dump these out to take a better look at them. Yeah, these are real good knobs. Look at that. Brass inserts, brass set screws, and on the big frequency knob, brass set screw and a metal plate. So these are really quality knobs. I like them already. And a eurorack power cable. So that's it. Now what we don't have is a build guide or a QR code to go to it. So I'm going to go to their website and find that and get the soldering iron heated up, and we'll get this thing started. They provide a pretty detailed build guide, a great bill of materials, and a bunch of photographs of the build, all of which, and the build guide itself has lots of good diagrams in it. So they've covered their bases on giving you the information you need to put this thing together. They do caution that it's a complex build, and if you're not experienced, don't dive into this one. So we're going to do the main PCB resistors first, and diodes, and there's a whole bunch of them here. Again, there's also a whole bunch of plastic bags, but I'll send them back to them. Maybe, I don't know, getting into Romania through the various postal systems might be a problem, but I'll figure it out. Huh, that's interesting. It starts off, the first one in the bag is two 10 ohm resistors that, again, I'm actually not looking at the build guide steps. Right now I'm looking at the bill of materials. I haven't looked ahead to see where we need to put thermal paste. Usually with eurorack you're not putting enough current through anything to need to dissipate much heat. So it'll be interesting to see who's putting out enough heat and absorbing enough current to need thermal paste dissipation. I didn't look real closely for it, but I didn't see a heat sink anywhere. I may have just missed it, or they may not use it. Now we'll do the 680s, R74 and R75. So I'm going to be going through all the resistors, and people who watch my videos know that resistor time is a time when I speed up camera playback and don't have any commentary, because there's not a whole lot to say about installing resistors on the board. If I find anything interesting, I will certainly break in with a comment, but I don't expect I will. So enjoy resistor time. That's resistor and diode time for the main board, and I actually his build guide shows doing the control board and then the main board. Since I picked the main board bag up first, I did that. It doesn't make any difference, obviously. Lots of resistors, reasonably good spacing. I didn't have too many issues with worrying about fouling or crossing points, even though I will say there are certainly some interesting resistor values. I've never had a 4K99 or what was the other one I was really surprised at? It'll come to me. But a lot of interesting resistors. 3M3, that's a big old resistor. I've not had that before. Just interesting. Now we're going to go ahead and put the IC sockets on, and the THAT, that 340, should be soldered without a socket because it won't fit between the boards if it's installed on a socket. So I'm going to do those right now. Let's see what we got. So we're going to do a variety of capacitors now. So you have to keep going back and forth. He doesn't always list things. He lists the value and shows you a graphical picture of where it goes, but doesn't list the number, like R27 or C3 or whatever. I would have appreciated the positioning numbers as well as the little picture, because the little picture often doesn't tell me what I want to know. And here's what he's talking about. This polystyrene cap is too big to fit with that socket there, so you have to put it on the back, and he thoughtfully provided a good mark there, but it does bang up against the pins, so I'm going to flush cut a couple of the pins here to give me a little more space to work with. I normally don't trim the pins on sockets, but I'm going to solder this one right away. So this poly is very thin. I'll be able to put that on the front of the board. It goes at C7, and that fits just barely. Don't have to bend the pins. That's in there very tightly. We'll have to be careful when we put that chip in there, because there's not much room. And 1400 nanofarads. It's a lot of 100 nanofarads. In fact, it's more 100 nanofarads than I want to do right now. I gotta go feed the cats. They're probably wondering where I am. So we'll get back to this tomorrow evening. Now we can dive into the 100 nanofarads. So all the 100 nanos are on. Now we'll do that chip, and then the power transistor and the other transistors. So first we'll get to that, and the reason why we're soldering this directly to the board is because there's a resistor that bridges over the top of it, and that adds extra height that they don't have if they add a socket to this. Now, since we're going to be soldering this down, tuck the legs in a little bit by pressing them parallel on the side of my workbench. Make sure the notch is going in the right place. Make sure you got all the pins through it. Look at that. This resistor is interfering with that. I don't know if I squeezed it down in there. He's packed this board pretty tightly. But I don't have to worry about holding the chip in place while I solder it. It's not going anywhere. And you can see there's an electrolytic capacitor that goes right next to it. So I'm going to want to lean it back a little bit so they're not directly interfering with each other. And now I'm going to solder this one in place before I position the other 3. Middle leg first, outer leg, outer leg. God, that's a big solder pads for these transistors. Okay, and here's a matched pair of 3565s to create the sine wave that we want. And we're going to go, and the flat sides face each other. Oh, we have an either-or transistor. So we've got the 5457 and not the 4339. So it's easier for us. The pad is a circular pad with a tab, and it doesn't show a particular orientation. So we've got to take the middle pin. The middle pin goes here, and the 2 side pins go here. So it takes a little bit of manipulation to get them all in, because they're a little offset from what you normally expect a transistor to be doing. And again, the components are all touching each other, or a lot of them are. That's kind of funny. And now we're doing the capacitors and the connectors and the electrolytic caps. I'm going to do the electrolytic caps first, then the connectors. Now we'll put a couple of trimmers on. Ooh, that pin's really bent. We'll put the non-bent one on first, or we'll put whichever one comes out of the bag first. Oh, they're both bent. Touch them up with some needle nose, and they are both the same value. Now we'll do connectors, and the female 14 pin goes on this side. And this electrolytic is going to hit it. Gosh, give me some room here, guy. Now we're going to put the other stuff on the back of the board. We've got the power connector. It's keyed, which I love. And it's got a little mark for the key, and positive and negative. And we've got one more connector to put on the back. I think this Molex is for expansion or something. I don't believe it's used right now. So those bits. Now we're going to take this Tempco resistor and we're going to place it across the chip, and I believe this is actually a heater. I believe this is a temperature controller, which is why it's called a Tempco, to keep that chip at a particular temperature, which probably keeps the goal is probably to ensure that the tuning is always right. But I need to grab some thermal paste. He does not include thermal paste with the build, so you have to find some yourself. Hopefully you have some in the shop. So let me squeeze out a little bit on this piece of index card. I'm going to go put this away, and let's see where this resistor goes, just to get a real sense for, because you really want it to be on top of the IC, or else it doesn't really perform its intended function. So I'm going to set it down on there and try and get it as even as I possibly can. Okay, that looks even, and it's going right, covering the bottom third of the T on the chip. So I will tilt it back a little bit, take my pokey thing, pick up the thermal paste. Gosh, that's going to be a lot. I'm really globbing it on there. And slide it back up. Get it tight on the board. And tight across the top of the chip. Get thermal paste all over my thumb. Oh no, I didn't. Huh, interesting. Now we'll solder this in place. A couple of one TL04 74, one TL72, and again they pack these. This tape is very tight. These are my 372s. I gotta dress the pins up. Fortunately, these are very common chips, and I have a bunch of spares in case I break a pin. Alright, that is the main board. So here's all this stuff. Electrical components that go on the main board. Control board. And then we'll put the pots and so on when time is right. And again, it's resistor time. There's a bunch of resistors to go on here. So I'll go into fast motion, fast replay, and do that. So let's see, now we'll put some diodes on this board. Ah, look at that, that's so tight. Ah, and these two resistors are right. These two resistors right here are just cramming this socket in place. Man. Adding 1 HP to give us a little room, give your components a little room to radiate heat off, probably would be a good idea. Oops. all the trimmers are the same value, fortunately. They're all 20K, so they'll be easy to put on. Now the LED, I'm going to put the electrolytics on now. The LEDs are also going on this step. However, I'm not going to solder them yet. I'll show you why in a second. Now if you look at this, he's clipped the leads. Whoever put the kit together clipped the leads, so you don't have a long positive lead. You have to rely on the negative stripe for positioning the electrolytics with the right polarity. I don't know where this last one goes. Where does the last one go? Oh, all the way down here by the logo. Now I'm going to double check. Polarities here. And now we'll solder them down. And the jack's on, but as you can see right here, the connector goes here and the jacks go here, and I've got to solder on this side because the connector's on the back. So I'm going to put the connector on before I put the jacks and pots on, so I can get at the pins without any particular muss or fuss. Because if I do it afterwards, then I'm soldering these pins between this pot and this jack, and I don't want to do that. So let me do one leg. Okay, I've taken the panel nuts off the jacks and the switch. However, I haven't opened the pot bag yet, but I looked in and there are no panel nuts for the potentiometers. They don't exist. I don't know why. Maybe it was a error in packing. I don't think I really care. It's just interesting to not have panel nuts when you need them. So we'll get all the... first thing I'm going to do is I'm going to put the two LEDs through the board. Now I'm obviously not going to solder them yet. There's one red and one green, and the board is fortunately marked red and green. Just drop them through, don't bend the leads, because we'll solder them once we get the jacks and pots put on. So I'm going to put all the jacks and pots on in rapid replay. I just remember that there are two different kinds of pots. There's 10K and 50K, linear and audio taper. Okay, so they're all on. One thing to note is this 25K is marked as 20K on the PCB, so don't be surprised. That's the second time there are different values in the build guide and parts list than there are listed on the circuit board itself. There were two resistors like that also. I apologize I didn't mention that earlier. So I'm going to tack two of the jacks at opposite corners. Then take the board, front panel, and put the front panel down to get everything aligned. See, that jack went cattywampus on me. Get back in there. lined up. Oh, I almost forgot the switch. That would have been silly. So it establishes the height, so I can go ahead and put the LEDs through. Now the question is, see, look at that. They go out quite a ways. If I want that, that's a little too far for me. I tell you what I'm going to do. I'm going to take a little piece of painter's tape and just have these flush, because it's a high-low indicator. It's the range indicator, and since the switch position gives me that information too, I'm not too concerned about being able to see the LEDs from the side. Sometimes I care about that a lot because of the way my studio is set up, but in this case I don't think I will particularly care. Now we'll go ahead and do all the other leads. Gonna take these two panel nuts back off. Okay, we've got the panel off, so we can put the last IC in. Okay, so the last IC is in, and now we're going to do one final pass to make sure all the soldering joints are completed, number one, and number two, that the quality is appropriate and there's no bridging or shorting. That board looks good. Look at the other one. Okay, now we're going to mate the two boards. Actually, there's a spacer or two. Actually, I'm not going to mate the boards yet. And of course, as I said the other day, I already got thermal paste on my finger because I touched it. We want to put some of these spacers on. Where does he mention putting the spacers on? The person who did this board is a man after my own heart. He's got lock washers to put on the screws. Now these spacers are good, nice beefy screws. Now when we're putting the spacers on here, you're going to want to do this a particular way, because the nuts he's included are fiber lock nuts. I mean nylon lock nuts, which I heartily approve of. But you're not going to be able to, it's easier to put those on first than the screw-in side, because it does take a good bit of effort to get the threads through there. In fact, I'm actually going to get a wrench. That's not going anywhere, and it's never coming undone, which is good. I mean, this is definitely a road ready. Where did I put the other lock nut? Okay, those are tight. Now we can mate the boards. All the pins are together and in the right place. Now we've got screws with lock washers. And double checking. That's the positive, that's the negative, and the red stripes on the negative side, as it should be. Now we'll put the panel on for final. So there it is. Let's start putting the pot knobs on. Make sure they're all counterclockwise. And there's how it is. Here's the front view, side view, back, other side, top, and bottom. Now it's going to be time to calibrate. We're in the rack. I have not turned it on yet. I'm going to go ahead and do that now, and we'll see if anything blows up. Got a green light, that's good. Now the calibration steps, the first step is to calibrate the resistors you'll need and getting a matched pair of transistors. We're going to skip over that because they supplied a matched set of transistors, and I'm going to make the assumption that they used the right value of resistor. Perhaps that's why the resistors they gave us did not match the value on the board. By the way, while we're waiting for all this to get set up, I'm going to go ahead and at least hear what it sounds like without any calibration. Okay, you can hear that sine wave. That's the low range. Man, that's putting out a lot. I'm putting my hand in front of my speaker. It's moving a lot of air. Ooh, that's nice. See how low that is? That's subsonic. That's really neat. So that's what it's sounding like. I'm going to go ahead and move it between waveforms. Triangle wave, saw wave, square wave. So it all sounds really nice. Now I'm going to go ahead and plug that back into the oscilloscope so we can do our calibration. I can remember where I put the probe. There it is. Let me slow this down a little bit. And then we want to get the sine adjust, so we're at about 4.2 volts. And where did I put my calibration screwdriver? And that one is on the back at the bottom. I'm sorry, I'm in the way of the shot. I'll switch to the the oscilloscope, so you don't have to just look at my back while I'm adjusting this screw. That's about 4.2 peak to peak. If we look at this being 2.6 per division, so that's 2.1 down, I'm going to say, or it's 2.06 down and 2.06 up, which comes out to 4.12. So we set fine frequency in the middle, because we're going to do some volts per octave calibration, and I'm going to use my tuner. As a reference, I'm going to use my even VCO oscillator, because I calibrated that the other day and it went pretty smoothly. So let me bring up my tuner. So that's C5, so I'm going to send that voltage over to this oscillator, and I'm going to get in roughly the range Now I'm gonna, oh, look at that. The linearity is really great already. There's C4. Now I'm not going to touch the linearity. It's doing octave to octave very well. You just got to set your initial, tune it like you would tune anything else. So let's just play around a little bit. Now let's try some of the other waves again. I'm actually going to take CV from my little sequencer. Let's speed the sequencer up. So that's the way she works. Sounds fine. Again, the calibration, I was prepared to do a lot of calibration on this, but I don't think I need to. It's very rock solid the way it is. So, a good unit, a complicated build in some ways, but a really nice rich sounding VCO. I'm going to enjoy using this. So that's the 259 VCO from, gosh, I forgot their name already. From Feedback Modules out of Romania. And the only problem I have, I'm going to show you right here, that is the wad of plastic waste from all the Ziploc bags I used. I don't like that. But other than that, a really fun little module, and I'll put it in the main studio. Hope you enjoyed the video.